Thank you for coming. All my information is on this page. We're going to talk about, obviously, blockchain, Ethereum, all these things. But the most wonderful thing is this thing called DApps, Decentralized Apps, and why they're called enterprise level, or at least for the purpose of this presentation, why it's enterprise level. So as a brief run through, although I am going to cover blockchain in some considerable detail, but I'm going to fly through it. I'm assuming most people will know something about blockchain or have heard about it as being part of Bitcoin. But I want to cover some things which are important, because part of understanding distributed apps ultimately is that the back end of it is all blockchain. So you need to know something about blockchain. And of course, if you've heard of Bitcoin, you'll know blockchain. So there's a little brief outline of what I'm going to cover. So let's crack on. So blockchain is pretty straightforward enough. Everybody knows that it's distributed, secure. It's held in some flat file or some database. Most people from a programming background know of linked lists, and on this particular case, it's a backlinked list. And Bitcoin was the first one to really utilize it. So at the end of the day, what we're really talking about is some data structures which have been used to hold information in a secure and distributed way. Okay, so Bitcoin, what is it? People obviously know the word Bitcoin, but ultimately it's really a protocol which was agreed on running on top of blockchain, which is how to make it so you're able to transfer digital currency and value. That's probably the best way to describe it. It's publicly available. It's a ledger, obviously, transactions, so you can transfer money. There's a reward system. I think anyone who's heard of Bitcoin will have heard of proof of work. I'm going to go and explain a little bit more of that so everybody's happy with it. Obviously, you have these things called miners, which everybody wants to be, because suddenly you become a multimillionaire if you happen to be a miner. So I'll cover some of that as well. Okay. Bitcoin, where did it start? Well, ultimately, everybody's heard of this name, Satoshi Nakamoto. The point is that nobody knows if it's a group of people or if it's a single guy, but ultimately this paper was released in 2008, which talked about, after the crash that we had in 2007-8, how to make a more trusted system without the banks in the middle. And this paper is like the de facto paper. If you ever want to understand where Bitcoin really came from, what it's about, why is it secure, I'd recommend you can Google this, and it's free. You can download it, straightforward. It's easy. Okay. When did it really start? I always like this part. Basically, the first block that was ever created is called a Genesis block with 50 coins. And you can see on here, that in 2008, the domain bitcoin.org was registered, Bitcoin design paper published, Bitcoin project registered on SourceForge, and so forth. And 2009, the first Genesis block in January 3rd was created, and so forth. It moves on. Okay. Now, again, a lot of people, I think, confuse what Satoshi Nakamoto main invention was. So his main invention isn't blockchain. It's actually the decentralized mechanism for emergent consensus. So this proof of work, this idea of if you have all this information all over the place around on different nodes, different computers, hosts all over the world, how do you come to a consensus? And actually that's his real invention. Okay, you'll see as I go on, you'll realize that actually that is actually only about the only thing he invented. The rest of it has been around for decades. Okay, history of blockchain. I'm not going to go through this. You can all see it started in 2008. Different, Bitcoin came, other cryptocurrencies came about. The main thing that I'm going to talk about that will help you understand decentralized apps is Ethereum. So what is Ethereum? Well, Ethereum was basically crowdfunded as a project in 2013, and you can see it raised 18 million. And obviously, it was with that money they managed to build it out. So it's a type of blockchain, and it was launched in 2015. It's interesting, by 2015, the amount of investment that was going into Bitcoin and blockchain and that sort of area, a top $1 billion, which is pretty quick considering, it was just launched. And it was 2015 that people came across this idea of, well, hold on, we've got this platform that has this thing called Bitcoin or all these different cryptocurrencies. But surely, if it can do all these fantastic things, we can use it as a backend, as a database. So if you have a client-server-based system, ultimately you have a database at the back end, or front-end app. In these days we've got distributed computing, we've got cloud computing, we've got mainframe, all of those. So everybody wants to. Oh, sorry, James, you want to raise your hand? Yeah, sorry. You're welcome. I'm trying to see if you want to say something, how I can make it.
Hi, Tahir. Sorry, James can't hear. He's just messaged me, but I think the others can hear. Can somebody else just confirm that they can hear all right? Because it might be his phone. Yeah, it must just be his phone. Sorry about that.
No, that's okay. Yeah.
Go ahead.
All can hear. Okay, wonderful. Is your mic on? Yeah. So, okay, wonderful. I'll just crack on anyway. If there are any, just raise hands again. I'll stop and check. So I guess the timeline is straightforward enough. And again, you can Google all of this if you want, but I just wanted to give you some background to it. Okay. So the key part, obviously, to do with blockchain, and as I said, if I was going to say to you today that there's a new way of writing an application where the backend has moved from a SQL-based to a NoSQL based platform, you'd have to know the database engine, whatever type it is, how it works, what it does, what can you do with it, is it performant, is it secure, obviously all those things. So this is why at the end of the day I'm covering blockchain itself as a technology. And blockchain, again, I come back to, it's all based on hashes. The only real concept I try to teach anyone with it is to understand that this SHA-256 secure hash algorithm, which is what SHA stands for, is basically what makes a block up. And this idea of a backlink list, as you can see at the bottom of this slide, you've got what's a block in. It's got a previous hash, this thing called a nonce, some information, some transactions inside that block, and then the next block that's created points back to the previous one. So that's just a fundamental concept, and I've given a link there for those of you who want to have a look and get your head around blockchain a lot more. All the information is at that link. Okay, the role of hashing, very, very straightforward. You put something in, it runs through this algorithm, and it pops out this massive number, but it's a fixed size number, and that's critical as well. This number that it pops out with these algorithms doesn't change in size. It doesn't get bigger and smaller, but it's fully encrypted. It basically tells you, so if you put ABC in, that's what it pops out. ABC with the uppercase C, capitalized C, you get that. And again, a whole line, a whole sentence. So for those of you who are familiar with hashing, you know, you can literally take a whole book, you can take anything you like, no matter what size it is, but it will produce a single hash. And from that hash, you'll know if something's changed or not. So it's a way of encoding it for you to understand if it's still valid. Okay. Now, the structure of a block is pretty straightforward. So it starts off what you can see at the top. I'll try to go into a little bit more detail with this as far as what's in it. So a block starts off with a block size, header, transaction count, a transaction, and it's turned basically into, once the hashing algorithm's done, the bits at the bottom. So we get a version to track software, protocols and upgrades. The previous block's hash is put in place. There's this thing called a Merkle tree, and I'm going to cover a little bit of that because that's to do with the performance side of things and how quickly you can actually search and find things. Timestamp a difficulty, and we'll go into that with proof of work and this nonce. Okay, so at the bottom I've got a remark. The block hash is not actually included inside the block's data structure. The hash is computed by each node as the block is received from the network. Okay. So, as I said, I could go into so much detail to do with the specifics of blockchain, but I think this is enough for today. Okay, this thing about arriving at consensus, and again, for those people, when you watch a lot of YouTube videos and things, they make it very simple. They make it look like it's just nothing more than a list of blocks connected together. Ultimately, for this system to work the way it's currently described, it would not work at all. It wouldn't be performant. So what you end up getting is this idea of when blocks are created, there's a height to them. And the idea is the more compute power you've had to put in place to be able to come to this consensus, the more the height of the block is. So on this one, the longest path, the height describes, represents the accepted chain. I'll cover this in a lot more detail, but maybe another day. I would love to cover this, but I think I'm just going to bore people with this, so I'll move on. Okay, if you want to see what blockchain in terms of it looks like, you can use browsers. You just go to a certain browser, to these sites, blockchain.info blog, and in that you can go to the different types of blockchains out there, and you can actually follow these public blockchains and find out what's going on, what were the transactions, and so forth. So all the information is there. And again, I believe Kelsey will send out this presentation to you, or you can sort of find this easily enough. You can explore the whole of the blockchain network. Oops, sorry. Okay. The Genesis block, I love this for me. The first thing in the Genesis block that was actually, as a transaction recorded, was this: the Times 03 Jan 2009, Chancellor on the brink of second bailout for banks. And that's what you'll see in the Genesis block. Okay, so a little bit tongue-in-cheek, but you know that's the Genesis block for blockchain in terms of Bitcoin. Okay, now the Merkle tree, named after Ralph Merkle, 1979, the purpose behind this is it's how blockchain actually really works at the end of the day, and it's to do with hashing. So for those of you who are true geeks, and I imagine if any of you have actually gone for an interview with Google, you'd almost think you're going to be asked all of this stuff and Big O and all these sort of things. And if you do, you're going to understand this really well. So the whole idea behind this is how to be able to navigate all these blocks and all these transactions very, very quickly to find what it is you're after. So as I said, if you were ever going for a blockchain interview as a developer, they'd spend a lot of time asking you about Merkle trees. Since I'm not here interviewing you, and I'm sure you're not looking for a job in blockchain, I won't go into too much with that. The only thing I do want to say is Ethereum is a Turing complete, and again, it's one of those geeky things, a platform for building much more complex applications. It uses a much more complex version of the Merkle tree called the Merkle Patricia tree. That's actually made up of 3 Merkle trees used for 3 kinds of objects. So you can see, because Ethereum came after Bitcoin, because they wanted it to be a lot more greater utility as a blockchain, they added more features in, and this was one of the features that they added. Okay, consensus and mining. So the whole idea behind it is that if you do have a distributed network of nodes and you are putting this blockchain, all this information all over these nodes, but you've got to come to a consensus that all these blocks are actually valid and what's being stored in them is truthful and so forth. You have this concept of what's called mining. So again, you hear about mining being where it's very CPU intensive. I think I read a paper back in March 2008, a few months ago, which said it's something in the order of 54 terawatts, which can power 5 million homes in America, and that's how much processing power it takes to be able to get this world state view that it's the blockchain, the network, and everything on it is actually valid. So it's a huge amount, and on that premise, that idea of getting it so you can see if everything the worldview is true and correct is this thing of proof of work. It's publicly auditable, fixed cost, problematic cost, and so forth. Again, the fastest algorithm, and people, these miners, these people you hear about, the idea is what they do is they mine, and I'm not going to go too much into what mining is. You can find it on Google and YouTube. But obviously, it's made to have a level of difficulty. So the person who actually resolves and validates a block is the one to make the money. Okay. Hash lottery. Again, hashing is straightforward but not challenging unless the goal is, say, find me a hash value. So all this is talking about, this slide, is that when you have a blockchain of network and you have all these blocks and you're putting transactions in them and you want to store them away, and I know everybody's going to put their hand up at the end and say, Tahir, you didn't use the word immutable. So I'm using that word and putting it out there. Yes, when you put something into the blockchain network, it is supposed to be there for life and you cannot change it. You can add to it. There's no such concept of deleting it or updating it. You are literally just adding to it. So the proof of work is a way of sort of confirming that something's been put into the network. It's now wrapped up, it's tied up, you can't do anything with it. The hash has been put over the top of it to say you will know whether it changes or not, and if somebody's trying to cause fraud or not to change it. So that's the whole idea behind this. Okay, this is the really clever part, and for those of you who know Bitcoin and blockchain, and I'm sure some of you will know it quite well, when Satoshi Nakamoto came up with this paper, the idea of this consensus actually came from this paper in 1993, which was to do with actually combating junk mail. So the concept of how do you actually create a consensus, but what Satoshi Nakamoto, he or them or a consortium, whoever it was, they took this paper, and it's out of this paper that really their paper in 2008 came about. So I hope this is a little bit of extra information for those of you who might not have known it. What was key is in the world of blockchain and Bitcoin and all this mining is, again, on one of the forums to do with Bitcoin, this person under the name of Quantum Mechanic in 2011 basically put this message up there which sort of said, you know, this proof of work that we're doing, there are a couple of problems. Not only are we chewing up a lot of power and consuming it, I don't necessarily believe that it's actually that foolproof. And he gave his reasons for it. So he put forward this concept of proof of stake. Okay, so the difference is, again, I'm not going to go into a huge amount of detail because I want to get to decentralized apps. You don't have miners or mining. You have what's called validators, and it's called minting and forging. So the concept is, rather than having a lot of distributed computers and hosts all fighting to be able to resolve this algorithm so they can earn this little bit of money, you basically have a slightly difference where you just pick validators, and those validators are specific people. And to go into a lot more detail, validators are people who basically say, right, I'm going to put some skin in the game, I'll put some money in, and for that I want to be able to make some money in terms of validate blocks. And I know people will say, well, that's easy, you just put a lot of money in and you'll become rich. To validate a block, you actually have to have more money, more skin in the game than the amount of money you're going to make. And even if you decide that you're going to leave, the actual network has a scheme where it holds on to the money for a certain amount of time without releasing it, to make sure you haven't done anything fraudulent to take that money away. So I'm just giving you a different idea of how these consensus mechanisms, and they are really important because they determine the speed, they determine the amount of horsepower you need, and so forth. Okay, I've covered this idea really by talking to you the way I have. I'm not going to go into too much detail. It's basically how much money you end up earning, how you get to it, to be able to win the mining race to earn some money. Okay, transaction confirmation. Have we got a question? I think I've got something I've seen. Why China has blocked the blockchain? What are the chances most of the governments in the world will accept it? How likely is it going to be successful? Is it a good idea to invest in blockchain? Okay, so China, it's quite interesting you say that. I have some friends who are working on blockchain in China. So the Chinese government has actually ratified blockchain for use only within China. So they do see the advantages of it, but they are just not allowing public blockchains outside of China. So that if you want to set up an enterprise blockchain, or you want to set up a public blockchain that you want to use in China, you can, but it has to stay and is regulated by the Chinese government. If you want more information, I can send you lots of links. Is it a good idea to invest in blockchain? Well, I'm glad you said blockchain and not Bitcoin. So are you asking, is it good to become, I don't know, a developer or a consultant or knowledgeable in blockchain? Can you just confirm that, and I'll help along, James? So I'll wait if you do answer that one, but that's the answer. Right, I'll carry on. Okay, so the next slide is this 51 matters. So this idea of blockchain and doing proof of work and coming to a consensus, it has this problem, which is what's referred to as 51% matters. And the whole idea behind it is when you are building something around proof of work and coming to a consensus, you've got all these pools, these people who've suddenly decided that they want to be the only ones who are actually winning the race to be able to validate a block. And those pools, as those pools basically grow in size and those people get together, what you're really not getting is a fair system, not only with the amount of money people are making, but you get this problem where the blockchain sort of mechanism of proof of work works. If more than 51% of the number of the network, the people who are mining or the network agrees that something is valid, then it's valid. But then you end up with this problem, which I've put in this chart. So these are some organizations that have come together and pulled together, and some of this sort of the collectively what number who are mining, who are winning the race to make money. But if you take the three big ones, BTC.com, Antpool, and Slush Pool, if you were to add those three together, they are over 51%. So this is actually one of the big issues and problems to do with Bitcoin and Bitcoin sort of rules that they have to do with consensus. So again, I come back to one of the reasons why you have proof of stake and all of these other mechanisms that people are coming up with is to resolve these issues, to keep this idea that you can't fraudulently do something on a blockchain. Okay, so to bring sort of this area to an end before I start on the DApps, the actual subject matter of this, there's a lot of alternatives. There's lots of different types of encryption. You can go into lots of different areas. And I know we've recently, almost about 2 years ago or a year ago, gone through where Bitcoin had reached a massive market capitalization and people have become practically billionaires, and then it's gone down again. Between you and I've played with Bitcoin, I've bought a wallet, I've traded sent some money across just to see what it's like. And again, I had to do that. And I started on Bitcoin and blockchain probably 2014. I think was the first time that I got my head around it and wanted to have a play with it. Okay, so the big thing that we need to get to, okay, Ethereum, everyone must have heard about it, and this 19-year-old kid called Vitalik Buterin. So he obviously looked at blockchain and Bitcoin and sort of said, you know, this is great, but surely we can make it do more. You know, maybe it's more than just recording information or transferring value in terms of money. And he created this idea of what he called Ethereum, and on top of it, this idea of a thing called contracts. Now, this is really what DApps is all about at the end of the day. So a contract is a computer program that lives inside the distributed Ethereum network. So again, just to clarify, Ethereum is just a version of blockchain with its own rules, with its own idea or mechanism of proof of work or consensus algorithm, and so forth. That's all it is. If you really want to go into real big detail, you hear about soft forks, hard forks on blockchains. So people take the code from, say, the blockchain that Bitcoin is made of, and they do a soft fork or a hard fork, and that also changes the currency and so forth. So I'm not going to go into details. I know that stuff quite well, but another day, if you want to go into that, I can always arrange something. But so you've got this. So he made this blockchain network and said, surely I can make it do much more. So he added this idea of contracts on top of it. So every time you send a transaction to a contract, so the idea being is rather than just transferring money between people, let's have some intermediary that does the job for you at the end of the day and take the middleman out. So at the end of the day, and that's basically, and do many other things. It's a virtual machine. You'll hear about virtual machines running on blockchain. So we've got another question. Let me just find that one. Just check that. Can we sort the problem like land acquisition? I heard TED Talks regarding blockchain, which mentioned that blockchain will help poor farmers all over the world by transparency in selling their land. Is it possible? Yeah, absolutely. I mean, to be fair with you, so much has been talked about how blockchain can solve so many things. And the whole idea behind it is that it takes that trust away from a single individual or a single entity and makes it part of the public network and all these nodes and all the people who are participating on it. You know, the best way I describe this is one of my young nephews asked me, tell me what is blockchain? And I said, you know, the simplest way to describe it is, if you go back in time, in the days where we didn't have computing or whatever else, or even ledgers, it was very simple. You lived in a village, and if you said, I have acquired that piece of land, and you acquired it from, say, another person, if there was only two of you and you ended up in an argument that was it sold or not for whatever value was exchanged, nobody could confirm that that was actually true. So you had a village council where you actually did your deal in front of the village council, and everybody in the council sort of said, yeah, that deal's been done. So later on, there could never be any issues about it. So that's the easiest way I explain what blockchain is about. Now, you're right. So people, when it comes to land acquisition, lots of other things, blockchain is the perfect tool. But at the moment, and I'll explain when I move along why, it's still early days. Okay, so go back to contracts. Contracts are maintained in the network without any central ownership or control. Contracts are written in any language. So now I'm going to get into more detail. Okay, so Ethereum, it runs on this currency called Ether. So its crypto fuel is this thing called Ether, and the Ether is broken down into what's called Wei. I won't go into too much detail. So think of pounds and pence. Okay. So let's come to DApps and Decentralized Apps. So there was this, by Forbes, there was this article this lady wrote in June 2018, earlier this year. Blockchain watchers say decentralized apps are around the corner. Now, again, I've given the link, you can read it, it's not very long. So basically what it is just like when Apple brought out the mobile phone, it was great, it was just another mobile phone, but it truly, what made the iPhone revolutionize and become the best-selling piece of equipment from Apple, and then obviously others with Google Marketplace, was the fact that you had apps on it. So this mobile phone actually became of more use than just making calls or sending text messages. So blockchain is now at that sort of pinnacle point, and one of the reasons why I'd said to that I wanted to present this is I really want people to understand that I'm a great believer that we have a piece of technology that is really easy to understand, and I personally don't see what's complex about it. I see recruiters, you know, changing their titles to now blockchain recruiters, and if you know blockchain, you can earn £200 a day more than anybody else. The funny part is I have no idea why, because it's so simple. Okay. So everyone will understand this, hopefully, who's on. When you've got a centralized network, say a central database server and lots of nodes, lots of clients, everything goes through that central point. So you're able to do all those fantastic things like atomic transactions. You can roll back, or you can commit, and all that lovely stuff. In a distributed world, obviously, where you have the network is distributed all over the place, if you were going to have two databases which needed to be synchronized, you do two-phase commits, all this wonderful terminology of how do you make them both stay consistent. It gets much more complex. When you're decentralized, and again, the whole idea of decentralized is that there is no control. No one entity controls anything. Okay, so part of the decentralized apps, the DApps, is understanding this concept of decentralized. And that's what we're really talking about. And that decentralized is possible because we're on a peer-to-peer network. So again, if you've ever used torrents, all these things in the past, which was a way of being able to share files, and it didn't really matter. That file was distributed on many computers. And if you wanted to download a file, the torrent would allow you, the torrent browser or the torrent client would allow you to download the file, but the file didn't come from one place. The file had pieces coming from different places, and it was all then aggregated down into one single file. Okay, so that's the idea behind centralized and distributed, and hopefully that makes sense. Okay, so DApps, at the end of the day, what is a DApp? Well, a DApp is a blockchain-enabled website. Well, it doesn't have to be a website. It can be a mobile app. It can be any front-end based application you can write is a DApp. It just, as long as what's at the back is a blockchain. Okay, runs on peer-to-peer network, not on a single server. Smart contracts, okay. So I'm going to try to, I actually thought about whether I would go into start coding and do some demos, but I've just taken some screenshots and I'm going to talk and walk you through, because I think you'll learn a lot more out of this session rather than watching me type, okay? So a concept that you must understand completely when it comes to enterprise blockchain. So what's the difference between enterprise and non-enterprise? Well, the concept is you've got to understand this thing of permission versus permissionless. Okay, so permissionless is Bitcoin, right? Anybody can download this little app called a wallet, and with that wallet, all you basically do is set that up. You get an address which it recognizes you as the owner of that wallet. When you transmit or buy or do anything, you're doing it to that address, that specific address. One of the recommendations they have in the world is that because you can create as many addresses as you want, if you're sending or receiving money in Bitcoin or all these cryptocurrency networks, you should always change your address and change them as often as possible. But obviously, you don't want to destroy your wallet or your address because you lose your money. Okay, so anything that's open in the public domain that anybody can access without any authentication or authorization is a permissionless public network. Where you get enterprise, you end up in the world of permissioned, because the whole idea of permissioned is that it's actually not available to the general public. So to give you an example, so the projects I've done to do with blockchain and enterprise blockchain is being in the health sector. That's where I've actually done most of my work. So I started doing pretty much in 2014, which was the time when I entered blockchain. I was asked to look at utilizing blockchain, which was being considered as a way to do electronic medical records. And how could that be secured? So it was very simple. It was like, well, you can't put it in the public domain because we don't want everybody going through and being able to look at transactions or what's going on. Well, there's one simple way. You take the blockchain and you put it on an intranet on basically your own company network where nobody else can access it, and it's just internally. But then the problem was, well, that's okay, but then everybody in the company can still access it. So hold on, we need a way to make it permission. Basically, you've got to go through authorization, and that's basically it. So it's just adding another component on top of blockchain and bringing it in-house, restricting it as to which nodes it runs on, and then making it so you have to authenticate. So the blockchain network knows exactly who you are and doesn't just know an address, which could belong to just about anyone. Okay, so that's the concept. And again, the table I put below underneath that, it gives you access information about the fact that permissionless is open access, permission is authorized access. So if anything you should get out of this presentation is the idea of an enterprise blockchain just means it is got permission and it's restricted to the number of nodes and its visibility to the rest of the world. But again, the blockchain that you pick to use, so you're not going to use the blockchain that is with Bitcoin because that's a public domain open, permissionless. Ethereum, but again, Ethereum has flavors of it and others which you would pick. The consensus mechanism, because again, you don't want all the computers in your company that you've put your own public blockchain on all competing and fighting to be able to spend more electricity just to come to a consensus. So the actual proof of work algorithms are very, very different. And as part of when you pick a blockchain network for an enterprise project, you would look at all of those as the requirements of what you need. Okay, and again, trusted validators pre-selected. Okay, so what is a decentralized app? Backend powered by smart contracts. We're going to look at that. Agreements between parties with automated execution that can act as a complement substitute. I won't read these through. Simply, at the end of the day, as I said, a decentralized app is a web app, a mobile app, a fat client, anything that's on the front that is communicating with the blockchain network at the back. Okay. Now, on the blockchain network, you've got this concept of smart contracts. So you might sort of say, well, hold on, when we normally write an application, whether it's mobile or web-based, These days, it's all about RESTful API, making AJAX calls to the back end, and being able to communicate to some endpoint to be able to prod it and say, here's some information, or give me some information. If you understand that concept, this is dead easy. It's exactly the same. So if you develop a front-end application, you go through the process of, you write it in some code. So if it's a web-based app, HTML, CSS, JavaScript, and the JavaScript with it is where you write your code for AJAX calls to the back end to talk to this API, and so forth, no matter which language it's in. Now, if you are using that language, or whatever the front end it is, whether if it's a JavaScript-based, you're using some libraries. And those libraries allow you to communicate. So if you're used to using JavaScript, HTTP libraries, TypeScript, HTTP client, you name it. I've got another message. Let me just find that out. It's like if you put your file at SharePoint, then everyone in the organization can see it as long as they have access to SharePoint. But if someone puts files in personal OneDrive, then only owner of the OneDrive can see it. It's a dynamic 365. No, okay, it's not quite that. Okay, what I'll do is I'll continue through, but I'll come back to that at the end. No, that's not quite right. Yeah, I mean, if you take SharePoint, yeah, SharePoint is the same 365. You authenticate with Active Directories. Once you're in, you can go everywhere, and people can in SharePoint designate which folders they can access, which ones they can't, and so forth. This is different. It's not at that sort of level where it's about collaboration, which is pretty much what SharePoint is all about. So this is about storage of data, but storage of data that is immutable, that is secure, and all these other things. So in SharePoint, if I put a document, there's no hashing. There's nothing that tells me, somebody's fraudulently changed it. So as I said, I'm not going to go into too much detail, but I'll try to answer more of your question later. So the big thing is, I just want to show everybody this. Okay, so what is that? Now, anybody who's done any kind of coding in JavaScript will go, yeah, that's a simple function. It says place order. I receive a value, an argument, place order. I print out console.log place order. Again, I'm not going to teach you how to suck eggs if you are coders, but if you look at that, if you're used to creating a class which has properties, which has methods, functions which are variables, or which are, again, methods or functions or inside them, this is a contract. That's basically it. So Solidity, which is the main language used to program in Ethereum, is so close to JavaScript that if you're a JavaScript programmer, you pick it up in about 5 seconds. It's that easy. Okay, so this is a contract. Now, this contract, you think, well, where do I write the code? What do I do with it? Well, again, just like any code, you have an IDE, Visual Studio Code, you choose whatever you want. You write the code in it, you compile it, and once you've compiled it, you've got to actually get the code, in this instance, because it's a contract, into the Ethereum network, so it's sitting there ready to run. So how do you get it up there? Well, first of all, what you do is, and I'll come back to this, so on here, this MetaMask is a Chrome extension that you can add into it, and if you download it and actually onto Chrome and install it, on that, what you're able to do is communicate with blockchains that you want the different types out there. And one of the things you do is you actually use that browser, and you can actually say, you know what, I've created a contract, I want to put it somewhere, and it'll say, okay, yeah, no problem. Give me the contract, give me the name of the file you want to put, and as when it's uploaded it onto the blockchain, ready for it to be utilized, it returns you an address and says, if you ever want to refer to that contract, here is the address. And that's the address you code into your application. So if you want to get to that contract, you basically just say, I want to talk to this address, and that's it. So again, Web3.js, there's libraries in JavaScript and other languages, which are purely the libraries that act as the communication between the front end and the back end. Okay, I thought to myself, you know what, I'll probably sit here and I'll do some coding, I'll do a web page, and I'll do a contract, I'll upload it, I'll download it, I'll compile it, and do all of those things. And then I thought, you know what, I'm not here to teach you how to suck eggs or code, because I suspect most of you can write some degree of code. So I'm actually going to ask you, if you if you want to look at all the apps that have been distributed and made out there, you can go to stateoftheapps.com. Definitely go to MetaMask, download it, have a play. But this educational portal, the link I've given you before, it's one of the best places I point people to say, you know what, if you've got a couple of hours and you want to become a blockchain and a smart contract and a DApps guru, just go to that portal and everything you need is literally there. So what I'm going to do today is I'm going to finish with sort of saying, I'm not even going to go into how enterprise apps and decentralized apps use tokens for value, how you have to pay to be able to utilize and make the smart contract run, because obviously you're using up compute power, so somebody wants you to pay for it. So you have to have some token, you have to have some value to be able to make your smart contracts run. But now we're getting into like the real depths of it. And if anyone genuinely feels you'd like to go into much more detail because the educational portal is not enough, more than happy to talk to Kelsey and let her know, and I can actually make this the most technical presentation you ever get if you ever want it. But I've hopefully tried to keep it to the point that I just wanted to spark some interest, and that was my goal in this presentation today. Okay, the other place I would like you to all consider, again, a really lovely tool, cryptozombies.io. You can go there. It is a child's play. I got my 14-year-old nephew to go and spend a couple of hours on this, and he was doing cryptocurrencies and blockchain. Sorry, I've got another question. Let's get that one. It's like if you put your, oh, sorry, no, I've got the same one or another one. Sorry, oh, there's a chat. Great webinar. Oh, thank you, James. So anyway, what I'll do is, guys, as I said to you, you can read this and Kelsey will get the presentation out to all of you. I'd love to have made this so technical that it was mind-blowing, but I don't think webinars are about doing that. But I'm more than happy to assist or help anybody if you do want to go down that route. Okay? So we'll finish with Q&A. Kelsey, all yours.
We'll just wait and see if anybody's got any questions to finish off. Q&A.
One. Excellent. Okay, good.
Oh. We've got, what is the hottest framework in 2019?
When you say hottest framework, are we talking which blockchain is the hottest blockchain to be working with and knowing? Well, it's Ethereum. That's a given at the moment. There are others. There's Quantum. Will the webinar be available on YouTube or somewhere? I missed some of the start. Yeah.
Yes. It'll be on DevHub's YouTube channel. I will put that in the email that'll go out to you all with a link to the video, and we'll notify you of the next one as well. It would be great to get you back to do a more technical webinar.
Yeah, if people wanted, as I said, I would happily have sat here and actually showed you how to do a simple web page, to do a simple contract, how to shove it up on Ethereum and all this sort of test blockchains that are out there, which you don't have to pay for to use, and so forth. Yeah. So,
so this has been run by DevHub North, and we're hoping to run one every month in a long series of webinars for developers. So you're all on the list now. We'll not bombard you with messages, but we will notify you every month when the next one's coming up to see if you'll be interested. You can also follow at DevHub North on Twitter, where we'll be sharing updates on there. And finally, after this webinar, you should be redirected to a feedback page. It would be great, because this is only our second webinar, it'd be great if you could leave some feedback, and we'll see what sort of subject you guys want to hear on the next one, and we'll find somebody suited to that. Be really grateful if you could leave the feedback for us. We've got another, hang on, we've got another question there.
Yeah, let's see. It says, for a public blockchain, do you have to have an energy guzzling proof of work, or is there another way? Yeah. So to give you an example, so the chaps at Ethereum, they've decided to change their proof of work to what utilizing something called Casper now. And similarly, the people on Bitcoin are looking at changing their algorithm as well, because this idea that the biggest problem they have is that the 51% math issue, where if you've got these pools now that are coming together and are able to sort of say, we'll all get together and we'll control 51% of the market, well, that takes away from the idea it's no longer secure. So yeah, I mean, there is a site, there are these what are called BIPs, which is Bitcoin something proposal, forgive me, where there's a big committee. Which crypto is your favorite? You're going to find this really, really hard to believe. Okay, so in 2014, I bought probably a couple of £100 worth of Bitcoin. And then I decided that I just wanted to play with it and nothing more than that. And I never bought any more. So when it's all gone up and made tons of money, I just look back and I never thought I should have kept it or anything. I just enjoyed it because the value I get from the Bitcoin and sort of a blockchain is the money I made doing the work that I do to solve solutions, not from sitting there and waiting for the share price to go up and down. So from my point of view, I don't have a favorite crypto because it doesn't matter. I can make my money in better ways. So that's answered that one. Can you repeat the name of that? Name of what? I'm not sure. I'm not sure, Don. I'm not sure. The non-guzzling proof of work. Well, the proof of stake, the one I just talked to you about at the moment, that's one mechanism where you're using validators rather than miners. So you can just search. There's loads of them out there that they're, as people are forking new blockchains, they're coming up with their own mechanisms, and some of them are to do with they want better performance and nothing to do with, as I said, it's not just about power, because you want to read and write, and you don't want to wait 9-10 minutes for the network to normalize itself to say everything is actually correct. You want it to be instant. Okay, I've answered that. Any more? Nope, it seems like we're done. Okay, I've lost my train of thought, so if I was somewhere, I've lost it.
Okay, well, thank you very much. That was really, really good.
Kelsey, I have a question for you. As possibly a non-developer techie, did you learn anything?
I did, yeah. I was, to be honest, I'm probably one of the few people out there who don't know much at all about Bitcoin, so it was nice to get a bit of an overview about that. Yeah, I enjoyed it.
Fantastic, thank you. Excellent.
Brilliant. Okay, we'll keep you all posted about the next one, and we'll hopefully have you back as well.
Lovely, I'd love to.
Take care. Have a lovely Christmas, everyone.
You too. Take care, everyone.
Bye-bye.